All right. Welcome back, everybody. I hope you all had a good lunch. And now we're going to continue PyCon Sweden for day number 1. But what did we cover today so far? We've seen Hugging Face, talk about NLP, applications, how to use Hugging Face. What else did we cover? There was a talk about hypothesis, writing unit tests without writing code, I guess. And there was also a workshop about building serverless applications. And there was another one. Using Redis and Raspberry Pi to do other IoT applications using object detection. So super cool, super innovative, and we're going to continue with innovation to a totally different company, which is doing something little bit different in Stockholm. It's a startup company in Stockholm called Fishbrain, and they are a social media app for people who go fishing. And they've built this app to help anglers find places to fish, what species they should be catching, and when to go fishing. So a lot of really cool applications. It's actually my previous employer. And they are going to present about graph databases. So this is Tetiana Kolmychek, and we used to work together on projects at Fishbrain. And she is going to present and talk about how they use Python to build cool applications to help people who go fishing. So I pass the torch to you, and take it away.
Thank you, Philip. Hi, everyone. I hope you had a good lunch, but not much to get really sleepy. Otherwise, I will be talking to a bunch of snoring people. And today I would like to tell you a little bit about graph databases and how to work with them to make your life easier and more efficient. So let's dig into enhancing your work with graph databases. First, a little bit about myself. My name is Tetiana Kolmychek, and I'm Ukrainian, but I have been living in Sweden for the past 5 years. I have been working with IT for more than 10 years, and the last 2 of them I have been really focusing on graph databases, integrating them, and utilizing their power to create new features and improve current features for our users. And if after the talk you would like to find me on social media, you can find me on Facebook, LinkedIn, or write me to my mail, tetiana.kolmychek@gmail.com. And as Philip previously said, I worked at a company named Fishbrain. It's the world's #1 fishing app, and we are a multifunctional app as well. So we have social media, we have a commerce shop full of gear that people can buy for their angling needs. And we also have a lot of utility functions such as bait guidance, catch location, depth maps, species recognition, spot prediction, and more. And the data we work with is also quite big. We have 15 million users, 14 million catches, more than 30 million regulation views, more than 100,000 items in our shop. And with addition to us using the data to improve the experience of our users, we also partner up with state and scientific institutions and provide some anonymous data for research purposes. So, as you can probably guess, a lot of my talk today will be revolving around the data. And data is something that is everywhere around us, and that is something that's really important for our work. If we think about data engineering, you cannot engineer without the data. They process, store, organize, transfer the data. As machine learning engineers, data scientists, and data analysts, we rely on the data as a foundation of our projects. We probably shouldn't build anything if we don't have the data for it to start with. As developers, we collect, process, and transform the data. And even as UI UX specialists, first of all, we rely on collecting and processing data to make the decisions. And we also work on the ways to present the user-friendly and optimal way to present the data. It's really hard to find a product that would not depend on it to begin with. And data comes in different form and shapes. It comes from the different sources. If you think about something like social data, commerce data, maybe some technical information like logs, metadata from images and videos, it's all really different, and it requires really different approach to work with it efficiently. So for that, we already have a bunch of nice and interesting tools to work with, right? We have different databases to optimize work with each data type. We have our relational databases like MySQL or PostgreSQL. We have document databases like MongoDB. We, of course, have key-value storages like Redis or Memcached. And we have graph databases like Neo4j or Amazon Neptune or Tiger Graph. Of course, it's not an exhaustive list of post types and different databases. And to work with each of the types of databases efficiently, of course, they use also different types of query languages as well. So before we will continue, I would like to get to know you a little bit better. So please raise your hand if you work with data on a daily basis. Quite a lot of hands. Now please raise your hand if you work with data that is stored in relational database on a daily basis. Still quite a lot of us. Now let's see how many people work with NoSQL databases on a daily basis. Okay, much less hands. And do any of you work with graph databases? Okay, I see a few hands. Not everything is lost. And I hope that after today, I can inspire at least a few of you to try graph databases more and maybe start using them in your daily work as well. So we did our small statistics here, but we can also look at the more global stats as well. This is a screenshot from dbengines.com. They are doing a database ranking, and they are doing it predictively based on a lot of different social factors and mentions around the internet, so it's not just pure use in production. But their methodology allows us to see the trends and predict which databases will become more popular before they start skyrocketing. And here we can see that out of top 10 databases, top 7 of them are relational, and only 3 are NoSQL. And it's quite logical. Relational databases are de facto the default databases. And they're great. They help us to store our data in a nice and organized way in tables, rows, and columns. They have transactions and rollbacks to optimize our work with data and ensure the data integrity. Why would we need anything else? Well, even here in top 10, we can see 2 really successful NoSQL examples of the usage and proof that NoSQL databases have place in our industry. Probably some of you worked with issues with caching, where your data would not be possible to deliver in a timely manner without cache. And I hope that most of you came to some sort of key value storage for the solution. And of course, search engines like Elasticsearch perform the best at what they were made for, searching. So looking at those 2 examples, we can ask a question. Why wouldn't we use graph databases for things they perform the best at? But before we will learn what graph databases are good at, let's take a quick recap and remind ourselves what are the graphs. Well, graphs are a mathematical representation of 2 things, set of objects and the relationship between a pair of those objects. And they consist of 2 main elements. It's edge, and or also called relationship, and the node. Graphs could be directed or undirected, and weighted or unweighted. That sounds quite abstract, right? So let's take a look at a few examples to understand what those properties and words mean. On the left, we have undirected weighted graph, and it could be a representation of a bunch of roads connecting cities. We can say that it doesn't matter which direction you go, Gothenburg to Stockholm or Stockholm to Gothenburg, so it's undirected graph. But the distance between different nodes, for example, Gothenburg and Stockholm and Gothenburg and Malmö, would be different. So this graph would be weighted. And on the right, we have directed unweighted graph. We can think about some social media like Twitter, where you can follow people, but it doesn't mean that they follow you back, which means that your relationship is one-sided, so directed. But for Twitter, it doesn't matter who follows whom, it's just a follow in the end. So this relationship is unweighted. So now that we reminded ourselves what graphs are, let's talk a bit about graph databases. If we think about the relational database that most of us are familiar with, what do they consist of? It's a table with rows and columns. And if you would like to represent a relationship in a relational database, you would need to use a foreign key. You would have a column in one table that points to a column in another table. And that's how you would understand that those two tables are related. And one of the top use cases for the relational databases would be transaction-focused operations. Now let's take a look at the graph databases. Well, they consist of graphs, so nodes and edges. And the relationships in the graph databases are considered equally important part of your data in addition to nodes and represented by edges. And as you probably can guess, graph databases are great for relationship-heavy data. We can take a look at a few typical examples of use cases of graph databases. One of them is fraud detection. Majority of the bank industry uses fraud detection in one way or another to find fraudulent users, prevent them from using the system, and maybe actually pinpoint a network of fraudulent users if they are interconnected somehow. Graph databases are great at this stuff. Another use case are recommendation engines, and specifically real-time recommendation engines. The whole graph in this case becomes your engine, and it can modify itself and produce you a recommendation real-time. And if any of you ever watched something like Intro to Graph Databases or watched tutorial video, probably those two examples would come up. But of course, those are not the only two. Graph databases are great at building something like customer 360-degree analysis tools, where you take the data from different parts of your system. For example, you have personal information of user, you have their shopping history, maybe you have their location history. Maybe you have some logs related to their usage of your system, where they go and what they look at. You would be able to combine all of them in your graph database and look and analyze all the data with a new angle and probably gather some new insights. And another example would be identity and data management tools. There are a lot of complicated systems that require a lot of access levels and not just blanket level 1, level 2 accesses, but with nuance. So you could have the highest access in one part of your system, but have only basic access in another. Graph databases could help you with that. And in general, if we are looking at the guidelines for when to consider using a graph database, we are probably looking at heavily connected data, some type of routing or logistical issue, any type of network like social network, IT network, and also graph databases could be a great tool for feature engineering as an intermediary step in your project. So, we talked a lot about the theory of graph databases. Let's take a look a little bit at the practical examples. And 3 examples that I want to show you today is something that I've encountered in the past 2 years, and where I found a good example of the graph database usage. First of them is called transactional. And some of you are probably thinking, well, you told us a few slides ago that relational database is great at transaction-based operations. And it is. But for some use cases, graph databases could be a great tool of choice as well. So let's take an example. We are a small startup company that wants to build a new Facebook. A lot of people have that ambition, right? And to start with, we just want to let people connect with each other. So we will build a table users and a table friends. And table friends will just have 2 foreign keys pointing to table users. And now, because we would like people in our network to connect more and more, we would like to send them an email to find more connections in our platform. And for that, to not just send random people, we would like to find friends of friends. So the tasks that we are trying to solve is find emails of friends for one particular user. Let's say that his email is ryan@example.com. Before we will jump into SQL and queries, let's just consider the algorithm of this operation itself. So first, we need to find the user Ryan. Second, we need to find all friends of Ryan. Then we need to find of all friends of each friend of Ryan. And finally, we would need to find all emails of all friends of Ryan. And this is an example of SQL query that probably would do this thing. We will not be going deep into SQL because I'm pretty sure you all can read it and parse it. But you can see that it has 3 joins, which is not a good sign for a performant query. And for the beginning, for a small startup, it still works great. We don't have that much data. Our time of response is not skyrocketing. But as people and connections between people start to grow on our platform, we encounter performance issues. And that's exactly what we encountered at Fishbrain as well. So what we ended up having troubles with? Well, first of all, with the amount of connections and users being really high, our query was really not performative real time. It could take up to 15 seconds to just calculate and return the data, and of course no one wants to stare at their loading screen for 15 seconds. So the solution, let's cache it. And it works, it returns data fast. But what's the problem? First of all, you don't recalculate hash each hour, meaning that the longer you wait between hashing periods, the staler your data becomes. And second, because we cannot predict which users will log in the next caching period and which will not, we have to create cache for all of them, meaning that we create a huge overhead in computing resources. Okay, so this approach works, but we are not satisfied with it. We decided to try the graph database to try and solve our issue. And for that, we took a really small, really simple graph structure. We added a node with label user and put there all the properties that we had in relational table. And we added one directed connection called friend. And full disclosure, for these examples today, we will be using a graph database called Neo4j and the query language called Cypher. And before we will continue, I'll just give you a quick overview on Cypher so you would be able to understand what am I talking about here. So Cypher is a query language specifically created for graph databases. It was created by Andrea Taylor in 2011 while he was working at Neo4j. And in 2015, it became an open language. So if you want, you can go and contribute to it on the GitHub. But unfortunately, it's mostly written in Java. Yeah. And if we are thinking about the SQL, the main statement keyword of the SQL is select, because we are selecting the data from SQL and returning to us. Well, in graph, we can think about the main keyword match as matching a pattern in our graph. And you can see that it pretty much repeats the structure of the graph itself. We have nodes, and we have relationships between nodes. We have labels of the nodes to separate types of nodes, like you would separate different tables in SQL. And we have properties which would be similar to columns in SQL. So what we are doing here, we are looking for a node with label user and a property email with value ryan@example.com that has a relationship friend directed to another user. And second user in this case is just a variable. You would be able to use variables in Cypher the same way that you are using them in SQL. And another interesting thing that you can do, you can return and assign to the variable the whole pattern, what we are doing here. So now let's go back to friends of friends. And this is an example of query that would be able to return all the friends of Ryan. So at the beginning, you can see pretty much the same. Label user, email property ryan@example.com. Then we are looking for the second degree connection to another node. And second degree just means not friend, but friend of friend. Exactly what we are looking for. And we are connecting it to another user. And of course, because it's not a direct connection, it can loop on itself, and we don't want to send Ryan an email about Ryan. So on the second line, we're just checking that we are not returning Ryan itself. and the output is pretty much the same. So, weird language, weird query, what did we achieve with that? Well, performance gain was really good because we were able to take just milliseconds to perform an operation per user with average amount of connections on our platform. And we were able to run it real time and on demand, removing all the issues we had with caching solution. So no more stale data and no more overhead on the computing resources. So example number 2 is a bit more intuition-based than strict steps to do to achieve success. And it's called analytical. This is our small network that we were working with before. And it looks nice, it keeps growing. But unfortunately, as it grows, we encounter the problems that a lot of social media have. Spammers. And as we deal with spammers that get reported, we keep getting new and new reports. And of course, we don't want our users to be disappointed, and we would like to find the problem and its root and eliminate it before any users have problem with it. So, looking at those two tables, we cannot really say who are spammers and who are not. Let's take a look at the graph representation as well, right? Maybe it's obvious. Well, looks like interconnected mess, right? You cannot say anything. But going from this representation, we can also think about what spammers are trying to achieve. First of all, it's really a bad idea to be a spammer if you create just one account. You put all the effort, you send a bunch of messages, and you get banned and you have to start from the beginning. So what spammers usually do is they would create a bunch of accounts and operate in high volumes. But just creating a bunch of accounts would probably not achieve the goal of getting to users and getting their spammer goal achieved. So what they need to do is they need to be a little bit more like real users. One way to do it in our small network is to create connections. So 2 ways we could try to investigate that problem, because we do not want to look at every user, right? And we want to narrow it down, is first, we could try to look for people with a lot of outgoing connections. People who start sending friends to everyone and trying to be everyone's friend. Another way to look at this problem is to see if spammers trying to boost each other to look like legit users and look at mutual connections in our network. So let's try and just take a look at the second approach, and we will just make a query that looks at all the mutual connections in our network. This is how it will look like. I hope you can see the query itself. It's really simple. And we seem to have 3 clusters of people, one consisting of 2 users, one of 3, and one of 4. And of course, if we have a spam report from one of the people here, everyone connected to them is instantly under suspicion. But let's say they are not. If we take a look at the right side, we have a pretty standard type of connection between people. Those people may know each other in real life. They may have found themselves on a platform and connected to each other. But then, if you take a look at the left, it looks much more interconnected, right? And sometimes clusters like those, they happen in real life. They're really small, really connected group of people all together on the platform. But if we look at our network, it looks like anomaly. And probably that is the cluster that we would first investigate. Did it completely solve the issue of finding the spammers in this case? No, of course. But it gave us an intuition to narrow down the scope and look in the right direction just based on the graph data representations that we chose to look at. And now let's move on to example number 3, data science. Probably most exciting example for me because that was the one that we received the most success with on our platform so far. So our network is doing well. After previous success of cleaning up spammers, people keep appearing in our network. We are starting to grow numbers. And as a company, we would like to promote a good message about sustainable fishing, because we want our users to be better and to do better. But if you just promote a message as a company, return of it is quite small. It's much better when the message comes from inside of the community. So what we would like to find? We would like to find the people who could be the voice of that community to bring the message. And for that, we would just like to find the influencers. Quite standard thing for social media, right? And first, we tried to do that with some relational database, Python, and Network X library for the Python. We uploaded our data set with directed graph, same as we did, and we just used a built-in function in Network X to calculate the page rank, and you can see the results on the right. Seems pretty fine, right? Well, as you can guess, we encountered performance issues again. What were they? The machine that we tested it on experienced a problem with memory, so we couldn't even load all of our data into a Network X graph, and we had to settle for a portion of data, and that portion of data took multiple hours to just converge the algorithm. Not ideal, right? With algorithm like PageRank, we would probably like to run it again and again, and we wouldn't want to buy 256 memory machine somewhere in cloud just to achieve that goal. So we took a look at the graph database again to see if it can help us to solve the issue. And for that, to our Neo4j database, we added library, same as we did with Network X in Python. Library is called GDS, or Graph Data Science, and it uses the same Cypher query language, but the interesting thing that it has, it operates inside of your graph database, but it compartmentalizes itself. So instead of doing operations on your graph, it creates a highly optimized for data science operations graph inside, does whatever you wanted to do, and then allows you to extract any results back. And here we are creating that GDS graph. It's really simple and easy, as you can see. And we are just using all of our data in the graph database. We are using our user label and friend relationship. And you can see the orientation natural just means that our graph will be the same direction as it was before, so directed in our case. And then we just do the same thing that we did in Network X. We are streaming the results back for each user. And let's take a look at the results. On the left, we have Neo4j and GDS output. On the right, we have Network X output. They look quite different, right? Something doesn't add up. Well, on the right, if we have any mathematicians in the room, we can probably see that all the numbers add up to 1, meaning our data is normalized. And on the left, you can notice already by Joanne's value that it's not normalized. And it may seem like a nuisance, right? That you need to normalize your data by yourself. But if you think about the use case of Network X graph and the graph database, they're quite different. In Network X, you would usually load your data, perform a bunch of operations on it, and load it back the results, forget about it. But graph database, same as any other database, is a living and changing thing. You add connections, you remove edges, you add nodes, remove nodes, etc. So not normalizing the data allows you to not perform each operation on the whole graph again. So with PageRank, you calculate it once, export it back, your data changes, and then you take that small portion of changed data and calculate PageRank just for it. Of course, you cannot do it to infinity. Once in a while, you have to recalculate it for the whole graph again, but it optimizes your life quite a bit. So for the sake of the comparison, let's just normalize the data in GDS as well. And now it looks the same, right? So we can say that algorithms perform the same. Well, great, problem solved. Well, we decided if you're already this deep, let's experiment and see what else can we optimize. And first we started with Network X and thought, okay, we cannot reduce amount of users we have in our network, but we can reduce amount of connections if we will just change the assumption about the direction of our connections. So let's just make them all undirected. And that's exactly what we did. Spoiler alert, it didn't help with performance. But we learned something interesting about the Neo4j. So here you can see that we just converted our graph to undirected and calculated PageRank for it again. Numbers changed a bit, but the general direction is still the same. And then we did the same with the GDS library. And here, as you can see, we just added orientation undirected for the relationship friend. So not a rocket science, easy to do. And again, we streamed our results back with a small addition of scalar property here, just to normalize it right on the output and remove all the extra work that we had to do in the previous example. And let's take a look at the results again. They seem to match, but not really, right? If you take a look at Joanne, she's pretty close. 37, 37.7%. Then you take a look at Matt, 21%, 19, not ideal. And then for some reason, Mary in Neo4j is really lagging behind everyone else, even though she is on the same level in our Network X. And here it comes again to the way that you would use both tools. In Network X, when you have undirected graph, that's just that. You have undirected graph that you will use for your operations and extract the data back. But Neo4j, as a graph database, gives you a bit more flexibility to structure your data in any way you'd like to. So first of all, undirected relationship in Neo4j is represented like two directed relationships. And second of all, it allows you to create multiple relationships of the same label and direction between the same two nodes. Why could you do that? Well, let's say you have two people messaging each other, and each time one person messages another, you would like to create a relationship with timestamp and the title of the message. Neo4j would allow you to do that. So what happened here? Well, when we changed the assumption about our data, we didn't actually change the data itself. So all individual directed relationships were converted into mutual directed relationships. And with Ryan and Laura and Brian, we had a mutual connection between them and another person, so they weren't influenced. But Mary had only one directed relationship, so she ended up having less relationships than the rest of the people for our algorithm. And this is just a small caveat to think about when you work with graph databases, and don't always assume that whatever you can do in Network X or similar tools that are using graphs but are not graph databases will be transformed the same way. Okay, so we talked a lot about the direct relationships, undirected. What results did we achieve with this? Well, they were quite significant. With usage of Graph Data Science Library and Graph Database, we were able to load all of our data to the same machines that we tried before, and we had the room for plenty more data to come. And it took just 30 minutes to calculate PageRank, and that's including exporting the CSV file of the results. Quite nice, right? So after me bragging for 30 minutes about successes of our usage of Graph Database, I hope at least some of you are thinking, I am hooked, but I have no idea where to start. Well, first of all, let's ask ourselves 3 standard questions of any data science project. First of all, do I have data? Quite hard to do anything with database without having data. Second of all, yes, I do have a data, but can I describe it through a relationship? And third of all, do I have a question that I would like to answer with the data? Hopefully, at least some of you can say yes to all of those. What can I recommend next? First, there are a bunch of open source and free tools that you can use as your graph database. So whatever you would like to try it on, your work project, your hobby, or your studies, you do not have to right away pay. Second of all, it could be scary to add a new tool to your project if you have just one possible application for it. But, at least as my experience showed, if you add a tool with a great example of use case, you nail it, performance is great, everyone is satisfied, all people start to think, how else can we use this great tool? And ideas just keep coming, and then you have to filter out how many ideas you can actually implement. Third of all, I'm sure a lot of you are working with big data, but when you will just start with your graph database journey, please do not put terabytes of your data in there. They will fit, but you probably will not be happy experimenting with it. Select a small subset of your data that you think is more or less representative of the whole, and just play around with it for a bit. Play with the data representation as well, because it will help you to discover new aspects to your data. And what is also important, play with data modeling. I'm sure a lot of you have kind of a background intuition for how to data model in SQL. Like if we think about creating a representation of many-to-many relationship in SQL, a lot of you will probably go to create an intermediary table. That's the type of thing that I'm talking about. And to help to demonstrate how data modeling can make or break your project in graph database, let's take an example of PyCon here. So the goal is to find a group of people that listened to the same talk. And the data that we have for it, we have everyone who attended the conference, we have everyone who gave talks, and we have a data on who listened to which talk. And let's start with really simple data structure. We have just two node labels, green attendees and pink speakers, and we have just one type of relationship between them, listened to. Can we answer the question with this data? Well, unfortunately, not really. If one person would be limited to giving only one talk in their lifetime, it would be more than enough. But fortunately, PyCon continues years after year, and people keep coming back to give more talks. Okay, let's try to add more relationships to find out specifically in which year people listened to a specific speaker. So here we have Henry, who listened to John in 2021, Sophia, who listened to 2020. Can we answer the question now? Yeah, we can. We can answer the question for year 2020. We can answer the question for year 2021. But it's not really optimized way of answering it, right? You would have to create a bunch of queries or bother with regex to set the relationship type. Not ideal. Okay, but we used all the data we had. Who attended, who spoke, and who listened to which talk. What do we do now? Well, let's take data that we already used and just change our perspective on it. So instead of connecting attendees and speakers, let's separate the talk as its own entity. And now we have our speaker John, who is a proud author of two talks, PyCon 2020 Keynote, and the famous How I Became John of 2021. Recommend listening. And now we have talk as a separate entity. So what can we do? We can create a relationship between attendees and talks instead of speakers. So here, even without collecting the people on the small data set, we can see the answer already. We have a relationship between attendees, Mark and Sophia, and PyCon 2020 Keynote, and same on the right with the second talk. And this is an example of a query that would produce exact answer to our question. As you can see, it's simple node label, relationship type, node label, and in the end, we just collect same as we would do in SQL and return the result. So I've bragged a lot today and talked a lot about benefits of graph databases. Hopefully, some of you are willing to give them a try. So let's, I would like to give you a few links. Those are for downloads of different types of databases. First two are the ones that I was referencing today. It's a Neo4j Community Edition and the GDS Library Community Edition. Both of them are open source, and they are going by the GPL v3 license for free usage. And they are both using the Cypher query language that we saw today. I also have here a link to the Janus graph, and it's also an open source and free with Apache license tool. It's using a Gremlin query language, which is a little bit different from Cypher. Cypher looks more like a SQL, and Gremlin more looks like some sort of a coding language closer to Python or Ruby. So choose your poison. And what's interesting about the Janus graph that it is a project under Linux Foundation, so they do not have any aspect of buying a license, but they do accept donations. Another database is a dgraph, also open source, also free under Apache license. What's interesting about this graph database is they have an ambition to be a first GraphQL compatible database. They are on their way there, and they're using GraphQL or dGraphQL query languages. And the last one is the Tiger graph. Unfortunately, this one is proprietary, but you can still use it for free from the cloud, and it's using the GSQL query language. And some links for future learning, if some of you would like to continue your journey in graph databases. First is a Coursera lecture. It's a general lecture about NoSQL databases, but it has a part about graph databases specifically. Pretty much all the databases that I referenced in previous slide have their own free training courses that you can pass on their websites and give a bit of a feel of how it is to use those databases. There is a book called just Graph Databases by Neo4j. It was published by O'Reilly, so if any of you have subscription, you can just get it there. And a few papers, one of them comparing performance of a transportation network between relational database and graph database. And another one is a graph traversal pattern paper. As a conclusion, I would just like to reiterate whatever I was talking about for the past 40 minutes. There are different types of data all around us, and the data may require different type of data representation. Relational databases are great, and we should not stop using them, not what I'm saying at all, but there may be more efficient ways to represent your data. Data with many connections, I'm sure a lot of you may have the data like that, may be the best represented with a graph database. And we may benefit from using different database types for different types of projects and tasks at our hand when we're asking different questions. And finally, please don't be afraid to look at your data in a different way. You might find something unexpected. Thank you for listening.
Cool. Super interesting, and super interesting to also see that in this audience, that there's a lot of people who know SQL, but at the same time, there's not a lot of people working with graph databases. So I think that, or I'm pretty sure that now you've inspired many people here to consider their data and think about it and say, oh, wait, you know what? Maybe we can use a graph database instead. And maybe we can also optimize it so it's fast. And I think that's really important. And also, I think it's really important because you are our second woman speaker for PyCon. And we needed to increase diversity. So, yeah. But yeah, let's move on to questions. Who has questions about graph databases, maybe about Fishbrain, anything about what Tatiana was talking about? There's a question. Should I pass it?
No, I can speak loudly.
Okay.
Do you keep your main persistence in relational database, or you completely migrate to graph?
I will repeat just so it would be everyone could hear. So if we are keeping our relational database and persistence there, or if we completely move into graph database, we are not moving away from SQL database, but we are keeping our graph database on the same level of update as our relational database, which allows us to use and query it real time without worrying about outdated state.
There is another question here.
Thank you. I asked about consistency. Can your graphs, can the graph databases, are they ASIC compliant? Can you put constraints on them and these sorts of things?
Yes, and they have transactions, they have indexes, they have pretty much the same set of database operations that you would be expecting from a SQL database.
No more questions?
How about Fishbrain? I have a question about Fishbrain. So what else does Fishbrain do that they offer to customers, and how to solve other customer needs? Like, what type of features does Fishbrain create?
Yeah, so as I said before, we are a multifunctional app. We have full social network experience, but it's revolving around fishing. So if you want to talk about any type of fish, if you want to brag about your cool catch, about your rare species that you call, you can come and post that on our social media. We also have a shop which right now is available only in US, but if some of you are traveling there, feel free to order. We also have a lot of utility functions, as I mentioned before. If you got something and you are not sure what it is, we have species prediction. So you can just try our ML algorithms and see if you will guess your species. We also have a lot of spot prediction, so we can help you to choose the best spot in your water body to fish. We have bait guidance, so we can help you to choose the bait for the type of fish you would like to catch in specific region. We have bite time. We are trying to predict when is the best time for you to go fishing for specific fish in the region, and much more.
Is that normally done in Python or other languages?
We have multiple languages. We have Python, of course, but also Ruby on Rails, some Elixir, a lot of React for our front end, and our client apps are using, I'm actually not sure what they're using, but something client app related.
Cool. Any other questions? Oh, there's a question. Yeah, go for it.
Who's close?
Sure, do you want the mic?
Yeah, I
Yeah,
can
do it loud
repeat.
because they're recording. That's why I was saying the mic, because I don't do it because we're recording and I want to hear the question.
All these predictions are coming from data driven by your users, or you have hired experts to help you with the, the type of baits and all this stuff?
So the question is all the predictions that I mentioned before, does the data come from our users, or is it our home experts that are providing that? And I would say 50-50. We are using a lot of the data that our users share with us, but we are also doing sanity check with our home experts, because fishing is a really peculiar hobby. If you will ask 3 anglers about their opinion on a specific topic, you will get 3 different answers.
Great. Any more questions for Tetiana?
I maybe can ask the question. Thank you very much for the talk. I'm very new to graph databases, and you talked a lot about pros, so about advantages of them. Can you please say about their limitations? What are disadvantages of using them?
Sure. Well, first of all, graph databases are really specialized type of database. So they are working great if you have a structure that supports being a graph. So if you will just put there a bunch of unconnected nodes and will try to use it in that way, they will not perform any better than a SQL database. So first of all, they will be great if your data fits. Second of all, of course, with NoSQL databases, a lot of them are used as a secondary database. So there is an overhead of creating a new database, setting up some sort of synchronization between your main database and a graph database. So if you don't have a strong use cases for using it continuously, it may not be great for real-time operations, but you can still utilize them for more analytical and data science purposes if you want to just upload your data, do a bunch of operations, and get a result.
Thank you.
All right. So, are there any more questions? No. Okay, so there's only a couple minutes left.
One
but-
more
Oh, there's another
question.
yeah.
Yeah, I thank you for the talk. I just had a simple question. You mentioned, so you showcased the capabilities of Cypher. Is there, I guess, an API or just a package in Python that allows you to interact with Cypher?
Yes, there is a driver, and it's officially supported by Neo4j driver, which are still main maintainers of Cypher. They support drivers to 3 languages: Python, JavaScript, and Java. But also, if you need drivers for other languages, there are some unofficial, so it depends on the language. But with Python, they have a pretty solid driver. It's using a bolt connection, which is a proprietary type of connection, but it is really fast, faster than querying it over HTTP, and it returns without an issues big volume of data.
Nice. Any more questions? No? Okay, cool. So, yeah, we have a couple minutes left, and I think we can wrap it up. But let's give Tetiana another round of applause.